So it's Christmas, and you think that the normal lights are too boring, and hanging reindeers and Santa Clauses from trees and whatever is pretty cliche, and I agree with you. So you go one of these. This is a laser light show. This is essentially a very small device that you plant or screw somewhere, and it produces nice little patterns on the things it projects. These are cool. This one has a remote control and everything, and it's great. I have another one set up that works perfectly. Now, I bought these two broken. Like, I didn't mean I bought them knowing that they were good and they came broken. I bought them broken for cheap. And I was like, okay, so I'll fix them. So the first one, I opened it up, and the only problem I had, the red diode was broken, and I didn't want to replace it and all that, so it only has the green working, which is fine, it already looks great. This one, however, the second one, had a bit of a bigger problem. So, oh yeah, I forgot. This video took me like a week to make, and it'll probably take me like 3 days to edit, because I've kind of overdone it with what I've decided to do. So please subscribe it to inflate my ego and make me feel better, or else I will feel like I would have wasted my time. This is or was the little control board of the device. So this in here had a PIC microcontroller, which doesn't have anymore because I stole it. And it has a little servo control and two light things, but this thing was broken. Both of the diodes were broken, the controller was lost, so there was like, this was nothing. So I was like, okay, what can I do with it? I could get the diodes and replace them, but they're over 5 milliwatts, they're class 3B, and I don't have to deal with that kind of thing. I like my eyes and I don't have goggles, like laser goggles to protect myself, so I'm not going to go into that. So I was like, okay, how would this look if you replace them with small 5 milliwatt lasers? And it doesn't look as good, but it looks serviceable. So I did that, and it looks pretty cool. So essentially what this video is, I'm going to show you how to make essentially your own laser light show, because all of these are brand new parts. I didn't use anything except the casing, but you can make your own casing. So that's essentially what this is. So yeah, let's make a DIY laser light show. So let's talk parts and everything we got here. So as I mentioned, we have two 5 milliwatt laser diodes with drivers included. These are like €2 each, and they are the heart of the build. They are what will project the lasers everywhere. Why they get two? Because two is better than one. Then we have servos. This is the servo that came with the old thing, with the old light switch. It's technically just a standard off-the-shelf servo, but it has this on it. This is called a diffraction grating. I also have a normal servo here, and if you want, you can just buy diffraction gratings off Amazon and eBay, cut them up into a square shape or a circle shape, and just put them on a servo, and you got the same thing. So that's that. Next, we have an ESP32. This is a Wemos Lowlink 32. It's a pretty advanced board. For this, you can get something way less advanced, and it'll control everything. This even has Wi-Fi capability, so I can control it through my phone, so that's pretty cool. And in here, I have a stepper driver board, drive the stepper through the ESP, and I have a low on-state MOSFET, which means it'll turn on with less than 3 volts, which is good because the ESP can only output 3.3 volts. On that, I got the casing here. This is the front of the casing with some more diffraction grating, so it splits the light up even more. And this here is the actual casing. And this is the mounting plate that I will mount everything to, so I can make it look all neat and such. So, first, what we should do, we need to manufacture two little plastic bracket holders that I can put here and here, because I'm going to place the ESP probably back here and the stepper board here, and since this is metal, I don't want anything to be shorted. So I'm going to go cut out two little plastic inserts here to put everything on. So then we can start placing and see how everything will go. So I got my little two squares cut out to place on here. One will go on here and the other one back here for the driver board and the ESP. But while I was doing some testing with the servos and the ESP, I realized that the servo that came with the old one was a 12 volt, not a 5 volt servo, and that is a problem because the driver board I have is for 5 volt, so I can't use that. So I was like, okay, I'll take this mounting plate that the old one had and I'll just put in the new one. Yeah, no, the new one has a little bit of a bigger shaft than the old one, so we're just going to go ahead and just solve that problem. After sufficient butchering, we have made the hole to way bigger than it was before, but now it fits the servo just fine. Just I have to adjust the mounting holes a little bit, but this should work. So I got the two plates mounted here with super glue, so they aren't coming off. However, this motor could not be mounted with super glue, so I hot glued the plate to the motor, and I hot glued the diffraction going into the motor, which shouldn't affect it in any way, I hope. So the driver for the stepper will probably go right here, and then the ESP will probably go back here. However, though, I am also going to make on this little piece of perforat an LM358 MOSFET kind of thing so I can turn on and off the diodes whenever I want, because it's a 3.3 volt system. It can't turn on MOSFETs by itself, so I'm going to have it drive some op amps, which will then act as a poor man's gate drivers, because I don't have any gate drive ICs handy. So I will add everything to this board, all the electronics, and make a PCB for the gate drive. So I have gone ahead and soldered everything where it needs to be soldered. The the little laser control board has been soldered to the ESP. So has the servo control board over here, and the little capacitor to let me upload. Now those two switches are a bit of a casualty. One of them is necessary. When I upload, I have to have this uh, open circuit, because if I have it closed, I will be powering the ESP from 5 volt and the USB, and that will break it. So I had to have a switch, and I added one more so I could turn it on without Wi-Fi. So I had to drill 2 holes in the case, which I did, but now that I've soldered everything and it's ready, I'm gonna go ahead and put it in the case, and we're gonna give it a try. Okay, so after what has definitely been a lot of torture, I finally got this thing in this enclosure. Um, this is much bigger than the old unit, so it took a lot of force to get it in there, but it did. So this here is a piece of glass to protect everything. It's a nice metal casing. And back here there are two switches that control either on and off of the ESP. So you would turn it off whenever you're uploading, because whenever you're uploading, you would take the glass off and like you get into the USB port that's right there. And this will, if you turn it off, will just run a set program if you don't want to control it through Wi-Fi. So that's basically it. And if you need anything about making the whole setup with the Wi-Fi, I'll leave a video below from Great Scott, who did a video on how to use ESP and App Inventor and things to make an app, which is a great video. If you want to see how to control steppers and all that, also there are way better videos than I could ever make on these, so you should go watch those. And other than that, this has been quite basic, and I hope I showed everything else. Now, this is the end of the video. I am going to show uh, quite a few shots of it displaying on my wall to see how cool it looks and how it works. But thank you for reaching to the end. If you have, I love you. Please subscribe to inflate my ego, and goodbye.